Yeah, good evening, everyone. Uh, am I audible?
Yes, sir. Sir.
Yeah, okay. So I'll just wait for a minute. I'm waiting for Afnan to join. So he want to discuss something. Before that, have you gone through week two content and having any doubts?
Yeah, I have gone through that, Arun, sir. So I had raised a few questions. I'm reading your answer now on the
Yeah,
discourse.
that's actually I have sent it to ma'am to get her response. So she has sent this to me through mail.
Okay.
Yeah.
It's actually confusing even now, but I think this is the
Maybe I can write more on that because I got the concept what she wants to
okay.
do.
Okay.
I just got it, received it, and copy pasted it. Yeah,
Sure. Thank you.
maybe I'll go elaborate that points tomorrow morning.
Yes. Yes. Thank you.
Anybody else? Anything on week two?
Yes, Nishant here. So for week two, we have a question regarding, I mean, unable to understand the algorithm means just to, can you walk through the complete example which is given there? So at least we can
Which one?
understand and ask.
Prime path.
Yes, yes, yes. The path probably I'm unable to identify the exact path from the source to the means, yeah.
Okay.
A
Okay.
simple example to walk through. Yeah.
I got it. Anybody else? Anything? Uh, yeah, Nishant, I'll do that. Before that, like anybody else? Anything? Okay, so. Uh, So the example I have done in last time also. The examples are there. So maybe I'll do it at the end. Is it okay, Nishant?
Yeah, it's okay. It's okay.
Okay. So Afnan, you have a plan, right, to discuss something? Is it the prime path or anything else?
No, no, no. Actually, I was discussing something about the RIPR criteria, right? The previous class. So regarding that only, I have a couple
So
of
Afnan,
points.
how much time it will take to discuss?
Nothing much, sir. Actually, there was this thing about which I had to,
Okay, then
like,
you can complete it. Then somebody wants prime path. So
okay.
about prime path, the video is already there, but I can again discuss, no problem. So let Afnan complete the thing. Then I'll go for it.
Yeah, definitely, sure.
Yeah, Afnan.
Yeah, so I was like preparing examples for the RIPR criteria that we have, right, in the test software testing course. So previously in the previous class, actually, I discussed that, and I think there was this mistake that I mentioned that PR is propagation in the RIPR, the short form, but it is not the case actually. So R, the first R is reachability, the second is infection, and the third P is propagation, and the last R is reachability. Okay, sorry, not reachability. Reachability is the first one. The last R is revealability. Okay, so about which we'll discuss. So I am planning to do one example for each. So the examples are still under preparation. I'm not sure if I'll be able to present it today itself. Maybe in the next session I'll do that. So the last one I wanted to just clarify that revealability and observability are closely related to each other. So I'll just reiterate those points because I think the previous live session I had made an overlook there and uh, did not mention it properly. Just give me one moment, please. I'll just share my slides and then after that explain it from there. I think somebody asked the question about the RIPR in the last live session, and I was explaining that.
Yes, I was asking that.
Yeah, it's the last, I think. Yeah, yeah. So the last R was different, rather. It was not propagation. So I just wanted to clarify that.
Yeah, got it.
Uh, Let me just. So the reason why I kind of connected the two, like propagation. So actually, we have discussed in detail reachability, infection, and propagation, as we'll see. Uh, but revealability is something that I think, as far as I can remember, we've not discussed it in much detail. Maybe it is because of the fact that this revealability is concerned with the fact that whether your test case. So these all are, in some sense, characteristics of your test case that you're trying to design, right? So we're talking about test case design, right? So in that, these criteria should be met. So for example, your test case should be able to reach whatever portion of your code you want to test. So that is reachability. Infection is it must be able to affect the state of the program, because if it is not affecting the state of the program in any way, then of course it cannot propagate, and therefore you cannot possibly uncover the error that resides there. And propagation is about whether or not the final output is changing, as we discussed also in the previous class. And revealability is that whether the error, the erroneous part is actually revealed or not. So I mean, in that sense, the observability and revealability are closely related to each other. But the fact is that propagation, we said, remember that when propagation happens, the failure is observed, right, on the outside. Therefore, I think we have not discussed revealability much, because when we ask for questions also, like for example, when we ask that which of the following test cases, let's say one question asks that which of the following test cases will uncover the error that is there. So we just try to give that test case whichever is able to cause a failure, as in cause a propagation, because of that error that is there, and therefore the final output is changing. So in some sense, you are already able to observe that. So you know that means that we are able to reveal that error, right? So but technically there is a difference, and to explain that in much detail, I'll have to come up with examples, so they are not ready as of now. Maybe I'll discuss with examples in the next live sessions about these four things that is there in the RIPR criteria. So about that, I wanted to make a note, and I think nothing specific as such. Anything else that anyone has would like to ask? If you can take questions before moving on. If anybody has any questions. Hello, Anand. How are you doing?
Hi, Afnan. Yeah, I'm doing good, thanks. I don't have any questions as of now. So I had a
Mhm.
few things on the discourse. I'm still trying to understand what Arup sir had, I mean, basically professor had written. But that's fine. I mean, Arup sir just mentioned that he will talk about it tomorrow.
Okay. Okay. Yeah.
Otherwise, I'm good. Yeah.
I saw that. Okay. Okay. Sure. So I think Arup sir will be taking one example of prime path coverage. Now that
Yeah.
we are into graph coverage criteria. So you can take that first. I'll see if I can produce an example meanwhile.
Okay. Okay.
Otherwise, we'll take that in the next live session. Okay.
Okay.
Yeah. Sure. Thank you.
So is it visible? It's the same graph we have in the slide, right?
Yes, it is visible, sir.
Okay. So what we need to do, we need to incrementally find the path according to the length of the path. So that says length of the path means number of edges it having the path. Um, Now, a prime path is something inside the path, none of the vertex will be repeated until and unless the end and start vertex is the same. Otherwise, none of the vertex can be like repeated within. So, like I can do still this 1, 2, 3, 1 because this one which is repeating, that's the first and end. Otherwise, this cannot be repeated. Like um, what I should say here, suppose I cannot take a 0, 1, 2, 3, 1. So 1 is repeating, but 1 is not the first vertex. So I meant to say this is a prime path because here the first vertex and last vertex is the same. Whereas if I try to take this 0, 1, 2, 3, 1, then it's not a prime path because 1 which is repeated, that's last vertex but not the first vertex. So vertex can
Excuse
be
me, sir. Sorry to interrupt you.
yeah.
One clarification. So you're mentioning simple paths, I believe, right? And not
Yeah,
prime.
sorry. Yeah, I'm mentioning the simple path. Yeah.
Simple path, right? Oh,
Yeah.
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 So to understand prime paths, actually, you have to first understand what simple paths are.
Simple path. Yes.
Yeah, yeah, exactly.
Okay. So let us try to find out first the simple paths. Yeah. Thank you. Yeah. I just confused. Yeah. So suppose I first want to find out the simple paths with the zero length. Right. So 0 length means those are the vertices itself. 0, 1, 2, 3, 4, 5, 6. Right. Now 6 is the final vertex, and you cannot have more vertices, like more path from 6. So I'll mark which is the final, like terminating kind of thing, which cannot be extended. The path which cannot be further extended. I have to mark that. Now I'll try to find out the path with length 1. Now from 0, what are the path we get with length 1? It could be 0, 1. Then it can be 0, 4. Okay. Then from 1, I can have 1, 5. Then can have 1, 2. Anything with 1? No. From 2, I can have 2, 3. Nothing from 2. From 3, I can have 3, 1. From 4, I can have 4, 4. It is a simple path because 4 is the starting vertex and as well as the ending vertex. From 4, I can also have a 4 to 6. So rather than circling this, we use some symbols to indicate the path cannot be extended. We use exclamation marks. So see, this 4, 6 cannot be further extended because I reached the final vertex. Right. Now 5, what I can have from 5, I can have 5 and 6. So I'll put again exclamation. So putting the exclamation means I don't have to extend them further. So no processing has to happen. Now one more thing has to be understood, that whenever I'm having a loop kind of thing, 4, 4, this is also something cannot be extended. If I want to extend it, like I want to go 4, 4, 6, then 4 becomes a repetition, right? So the loops will be marked with a star. That means we do not extend this also, a loop. Then next, I'll try to find out the path with 2 length. So if I have 7 vertices, maximum I can have the path length, that is 5, right? 6. 1 less than the number of nodes, right? So 7 nodes, so I cannot have a path length which is more than 6. So now with 2, I have a 0, 1. From 0, 1, I can go 0, 1, 5, 0, 1, 2, 0, 1, 5, and I can have 0, 1, 2. Now from 4, 0, 4, I can have 0, 4, 6, which is the final. I cannot have 0, 4, 4 because that is not a simple path, right? Then from 1, 5, what I can have? I can have 1, 5, 6. That's the end. With 1, 5, no more. 1, 2. With 1, 2, I can go up to 3. Right? Anything else with 1, 2? No. 2, 3. I'll have 2, 3, 1, 2, 3. Nothing else. With 3, 1, let us check out 3, 1, 2. I can have. Then with 3, 1, I can have 5. Okay. This is with 3, 1. Now 4, 4 I don't need. 4, 6 also I don't need. 5, 6 also I don't need. So this is up to 2. So let us go for the path length with 3. So with 0, 1, 5, I can extend it up to 6. So I can have 0, 1, 5, 6 final. 0, 1, 2, I can have up to 3. 0, 1, 2, 3. Now see, if I have a 0, 1, 2, 3, now this path cannot be extended, because if I try to extend the path, I'll have 1. So 1 will become repeated, right? So 0, 1, 2, 3. So this is a final. This path also cannot be extended. You got no 0, 1, 2, 3. Then if I want to extend it, I have to go definitely to 1. So it not remain a simple path then. Then 0, 4, 6 already reached the final. 1, 5, 6 already reached. 1, 2, 3. 1, 2, 3. I can go 1, 2, 3, 1 star. Right? It's a loop. This also cannot be extended. Then we have 2, 3, 1. So 2, 3, 1, which can be extended to 5. 2, 3, 1, 5. Right? 2, 3, 1, 5. Then with 3, 1, 2. 3, 1, 2. 3, 1, 2, 3.
And 2312 is also possible, right?
2, 2, 3, 1, 2. 2, 3, 1, 5. Oh, yeah. Yeah, I missed it. 2, 3, 1, 2. It's a star, right? Yeah,
Yes,
thanks.
it's
Yeah, so 3, 2, 1, 3. 3,
Sir,
2, sorry, 3,
sir,
1.
the second one on the third level, 0, 1, 2, 3, should that be a star or?
No, 0, 1, 2, 3 cannot be extended
That's a
because it's
star,
no
right?
more.
Yeah, it cannot be extended, but it's a loop.
No, it's not a loop, right? 0, 1, 2, 3 is not a loop.
it will be
Uh,
loop in level 4, not level 3. Yeah. So
but why is it an exclamation there? Because it's not ending with 6.
It is not ending with 6, but it cannot be further extended. That's the rule is here. Because if I try to extend, see, if I'm having a loop, then I put a star. But if I find a path which cannot be extended, then I put a exclamation. Its loop means also it cannot be extended, but especially for loop, I put a star. So, but
Okay.
it is not getting a loop actually. It's basically 0, 1, 2, 3. But I cannot extend it because if I try to extend it, it no more remains a simple path. That's all.
Okay.
So do we put a loop if there is a star? Sorry, do we put a star if there is a loop, or
If
it
it is a
starts and
loop, I
ends?
put a star.
Okay, so there's no need for it to start and end at the same one, no?
Definitely. If it is a loop, then it will be starting and ending with the same node, right?
But in 4, it's let's say 0, 1, 2, 3, and 1. Do we put a star in that case?
0, 1, 2.
3, 1.
See, then the simple path means the starting vertex and ending vertex must be the same, right?
Oh, right. Yes, sir.
You cannot repeat otherwise. One is getting repeated, but it's not the starting one, right? So we cannot extend beyond 3. That's the point is.
So we're doing only simple paths.
Yeah, we take only the simple
Yes,
paths.
sir.
So if in that case, if you just see 2312, we can do a exclamation at the second level itself, right? 231 instead. Uh, yeah, 2312. So we can put exclamation at the level 2 itself. Is it right? Because
2, 3,
we can
1.
think that it is going.
No, if
Yeah.
I repeat the node, if it is the starting node and ending node, it's allowable because I can consider a loop. But
No,
one
I'm
of the node
saying,
can be repeated in between.
sorry. No, it will see you 0, 1, 2, 3. In that case, you think that it is running in loop, right? 0, 1,
No,
2,
I'm
3,
not
because it is
running.
coming one
Loop
in.
is acceptable. Again, I'm saying loop is acceptable. The thing is,
Excuse
if
me,
it is
sir.
a
Can I take
simple
this?
path, I can repeat a node if it is the starting and ending node. Otherwise, I cannot repeat a node. That's all.
No, no, that I got it. So see, I just wanted to clarify. I may be wrong here. 0, 1, 2, 3. You put exclamation because at level 4 it is going to be a loop, right? It's not at the level 3. Level
No,
4
it
when
is
we
not
have added
wrong
another
because it is a loop.
one.
See, it is not wrong because
Okay.
it is a loop. Try to understand. See, if I consider this path 1, 2, 3, 1, then 1 is getting repeated. 1 is the starting and ending. But if I do 0, 1, 2, 3, then I repeat 1. 1 is getting repeated, but 1 is the intermediate node. So this is not possible allowed in a simple path.
But that will be come in the level 4, not level 3, right?
Yeah, that is
0, 1, 2, 3
yeah, that is I'm saying.
is
See, if you
allowable.
cannot put a 1, that means beyond 3 it cannot be extended. Beyond 3 you cannot extend it, right?
So in that case, if you just think of 1, 2, 3, and let's assume for a minute that 5 is not there. Okay, 1, 2, 3. So, sorry.
If I have 1, 2, 3, can I extend it? I can still extend it.
No, sorry. 2, 3, 1. Sorry, 2, 3, 1. 2, 2, 3, 1, 2. Sorry, 2, 3, 1, and 5. 2, 3, 1.
2.
If 5 was not there,
1 minute.
yeah,
Let me
just
write
write
it.
2,
2,
3,
3, 1.
1. Okay, that's at level 2, right? If we go with and if we just assume that 5 is not there, so can I put it exclamation in level 2 itself? 2, 3, 1, and 2,
I
because
can
we
still extend it to 2. It's allowed, right? Because this is also simple path. See, the node getting repeated, it's the starting and ending node. So this is allowed. But the repeating node cannot come in the intermediate, like within the path.
Okay.
If it's starting and
So
ending,
that is the formula for simple path.
Yeah.
Okay. Got it. Yeah. Thank you so much. Yeah.
So where we were? 3, 1, 2, 3. 3, 1, 2, 3. Yeah, I cannot have more. 3, 1, 5. 3, 1, 5, 6. 3, 1, 5, 6. It's an exclamation. Now still I can extend one path, that is this one, right? So I can now still have a 4L path. 2, 3, 1, 5. 2, 3, 1, 5, 6. 2, 3, 1, 5, 6. So all the paths are like simple path I have got. Now if the question is find out number of simple path or find out what are your simple path, all the path you got which is ends with the exclamation and star, these are all simple paths. So you have to count them all. So this 1, 2, 3, whatever you have, all are basically considered as a simple paths.
So do you mean prime path?
No, simple paths. Till now I have simple paths.
Excuse me, sir. One point I want to add here. So when you say that we are counting simple paths, we are also including whatever is not having that exclamation or a star, right? without that also, like 231, we are also considering that,
Yeah,
I
I'll
believe.
go for that. So first of all, like I'll have
Mhm.
the number of simple paths, how I'll count that all the paths which is ended with a star and the exclamation, those are all of my simple path. And along with that, each of the single node also counted as a simple path. Along with each of the single node also will be counted as a simple path. So all the single node along with exclamation and stars, those are all simple paths. Now next job is we need to find out the prime paths. So prime paths must cover all the simple paths. Prime paths must cover all the simple path. So as per the thumb rule, we should always start with the longest simple path to cover. So I want to find out the prime paths. So
Sir,
now,
can I ask one question?
yeah,
So for example, if I take 2315, that should be a simple path, right? Because it doesn't have any repeated nodes in it. So let's say 2315. So looking at the third level, the fourth row, you have written 2315. So even though that doesn't end with a star or an exclamation, it should be a simple path because it doesn't have any repeated nodes.
mm,
I think those calculations are yet to be completed. So I think until we reach to the star or exclamation, we'll have to do that. Then only we'll decide on the simple path.
No,
give
no.
me a
So
moment.
so I'm talking about the
Right?
definition.
I mean,
So I think the ones which are ending. So I refer to the book also. So
Yeah, maybe, yeah. 1 minute, give me a moment.
yeah,
Maybe I'm
sure.
getting a little confused here. Let me find out. 1 minute.
Excuse me, sir, may I add something?
Yeah.
So yeah, that is technically correct. Like whatever paths we are computing, right? Whether or not it is ending with exclamation or asterisk, it doesn't matter.
Those are all simple path, but
Yeah, including the other ones also, sir. Whatever is not extended, right? So let's say simple
huh,
paths of length 2 that is there, right? So or for yeah, so length 2 is 231, for example, 2L, right? This one is 231. So this is also a simple path, irrespective of whether it is a loop or like ending. It doesn't matter, right? So we'll have to count all of them, I believe. Yeah, in that case. As
Right.
for
So
the yeah,
a-
as
anywhere any path which doesn't have a repeated node is a simple path. That's the definition I get.
yeah, of course, and
Right?
then
Okay.
the prime path is a maximal simple path. Okay, so
Maximal
yeah,
simple path. Yeah.
exactly.
Right. Right.
So you have a simple path, which means there is no repeat except maybe possibly for a loop, and you understand how a loop looks, right? So wherever you
yeah,
start, you end at the same place, right? So that is
yeah, that's correct. That's correct. I'm going
hmm.
wrong a little bit here. Somewhere I
no,
got
I
confused.
think probably there's some confusion in the assignment. We have this problem, and they have specifically mentioned that only the exclamation and the star will be counted as a simple path, not even the single node. So I'm not sure exactly. And that there's one
Which assignments?
app is also
No,
the
no, that
week two
app
assignment.
doesn't get the correct thing sometime. That app doesn't count all the single nodes. Okay, let
Mhm.
me count the prime paths, then I'll come back to this. Okay, I'll just,
Yeah, please. We need
yeah,
to have some
let me
clarification.
complete
Yes,
this,
correct,
otherwise
correct.
I'll
Yes.
forget. So, I want to find out the prime paths. So, prime paths are the max of these things, simple paths, and it also subsumes other uh, simple paths also. So, that's why we need to start with the longest one. So, longest one is here 2, 3, 1, 5, 6. So what are put with the exclamation and the asterisk, those are basically the longest possible, but I need to find out that is already subsumed within another path already also. So if I took this 2, 3, 1, 5, 6, here I have 3, 1, 5, 6. See, this 3, 1, 5, 6 already having an exclamation, but it is we already subsumed within this prime path, right? 2, 3, 1, 5. So I don't have to repeat it again. So I have 3, 2, 3, 1, 2, 3. So this is a new path. 3, 1, 2, 3. So I took this. 2, 3, 1, 2. So this is also a new path. 2, 3, 1, 2. Then next I have to look for this 1, 2, 3, 1. So 1, 2, 3, 1, is it covered anywhere? No. So 1, 2, 3, 1. So I took this also. 0, 1, 2, 3. 0 I haven't took anywhere.
Sorry, Sattva, how you are picking up this prime path? What is the rule you are picking? Because I didn't
See,
follow
whatever
this.
having the
So you
exclamation and star, those are basically the longest possible simple paths, right?
okay?
That because those are cannot be
Okay.
extended further, right?
So you are picking up all the longest path, which are mentioned star or exclamation that you are putting in
Yeah, I'm
the.
picking up, but I'm also checking if some path already subsumed by another path. So that's what. If I take 2, 3, 1, 5, 6, here I have 3, 1, 5, 6. So 3, 1, 5, 6 is already subsumed within this path, right? So if I'm testing 2, 3, 1, 5, 6, there is no need to take 3, 1, 5, 6 again.
Okay. Okay.
So I have gone to 0, 1, 2, 3. So this is a new path. Then I have this 0, 1, 5, 6. Okay, so I took all three. Now with the 2. With the 2 I have 1, 5, 6. Do I have 1, 5, 6? See, 1, 5, 6 already here. 0, 4, 6. 0, 4, 6 I have to take. Anything? 0, 4, 6. Okay, then 5, 6. 5, 6 I have covered. 4, 6. 4, 6 is covered. 4, 4. See, 4, 4 is not covered yet. Right, 4, 4 is not covered yet. Okay, 6 is covered. So it's done. Basically, we are having these are the prime paths. So now, the question could be asked in a way: the test requirement for a prime path coverage or number of prime paths. Both are the same things. So the test requirement for the prime path coverage are basically the prime paths. So these are the paths you need to cover by the test paths. So what are the test path? So test paths are something which starts with the initial node, end at the final node, right? So here also, whenever deriving the test path, so we need to take the paths from the starting to end vertex in a way so that these prime paths could be covered. So here also I start with the longest path. So here I have 2, 3, 1, 5, 6. See if I have 2, 3, 1, 5, 6. How I can cover this? 2, 3, 1, 5, 6. So I have to start with a 0, 1, 2, 3, 1, 5, 6. This is a way I can cover. So I can take 0, 1, 2, 3, 1, 5, 6. Yeah.
Sorry. Can how you arrive this? Sorry. 0,
So
1,
it's a
2, 3.
2, 3, 1, 5, 6. 2, 3, 1, 5, 6. I have to have a test path. A test path means it should start with the starting node, ending with the final node, right? So if I have to
Right.
cover this 2, 3, 1, 5, 6, so I have to start it with 0, 1, 2, 3, 1, 5, 6, right?
Right.
Yeah. So next is 3, 1, 2, 3. Now again I have to see this 3, 1, 2, 3 is already covered in the test path or not. No, it is not getting covered. So I have to again find out 3, 1, 2, 3. So 3, 1, 2, 3. So I can take 0, 1, 2, 3, 1, 2, 1. So what I can do again, I need to cover 3, 1, 2, 3. 3, 1, 2, 3. So I have to take 0, 1, 2, 0, 1, 2, 3, 1, 2, 3, 0, 1, 2, 3, 1, 2, 3, then 1, 5, 6. Now again check out if this is already covered. 2, 3, 1, 5, 6. 2, 3, 1, 5, 6 already see covered in this. So you may 2, 3, 1, 5, 6 already covered in this. So you may remove this test path because it is already subsumed over here, this test requirement. So it is basically fulfilling this one and this one both. See, 2, 3, 1, 5, 6 I can get here. 3, 1, 3, 1, 2, 3 also I can get it over here. Now let us check out 2, 3, 1, 2 is there or not. See, 2, 3, 1, 2 is already covered.
Sir,
So
sir, can I interrupt?
yeah,
I don't think we should do that, because the second path that you have written is actually doing 2 iterations.
yeah.
So you should keep the 2 iterations and the 1 iteration and 2 iterations separately. That's what I saw in the textbook.
Yeah, so that's a case like you have to, but the questions like sometime like they comes like you need to find out the minimum test path which will cover all the prime paths. So
Oh,
that
okay.
is a ideal situation like where we exercise the path for a 0 execution, 1 execution, multiple execution, right? But if I want to minimize the test cases, to cover all the prime paths, our objective will be to find out those paths which will cover all the test cases, test requirements rather. These are not test cases, these are the test requirements. So if I can create a path like this, we can see we can cover these as well as this. But in ideal case, you should go for a 0 iteration, 1 iteration, multiple iteration. Okay, so
Okay.
next, if you find out this 1, 2, 3, 1, this is also got covered in this. 0, 1, 2, 3, this is also getting covered in this. 0, 1, 5, 6. So this is not getting covered. It is 0, 1, 5, 6. This is without any iteration. 0, 1, 5, 6. 0, 4, 6. 0, 4, 6, this path. Skipping the self loop. 0, 4, 6. And 4, 4. That is 0, 4, 4, 6. So I'm basically getting 4 path. Yes, yeah, ideally you should also consider this, but minimizing path, this should be the result. If you look at, so we get the paths like this, the test path like this. One is this path 0, 1, 4, which is skipping the loop. Then we get one that is executing along with the loop. We get a path here which is skipping the loop. And also we are getting a path which is exercising the loop. Like this. Okay. So that simple path question, I'll come back to that after some time. Let me check. I'm having a little confusion here. Yeah, Apnan, you want to go for the next thing? By the time I'll...
No, sir. I wanted to present examples for this the difference between
What you
infection,
want to
propagation,
say?
and all.
Yes. Sorry, Nishant, what you means? Sorry, I got
Yes, sorry. So, yeah, so by see, I got it this prime path. Now, can we just talk about the node coverage and this edge coverage as well, please, on the same example?
yeah.
If we just extend it,
Huh.
please. Yeah, thank you.
So node coverage requirement is all the nodes should be covered. So requirement will be number of requirement will be just 7. That is, you should cover 0, 1. Sorry, you should cover 0, 1, 2, 3, 4, 5, 6. So basically you can cover within 2 paths, right? So you can cover. So if you go like this, you can basically cover. So if you get a path 0, 1, 2, 3, 1, 5, 6, you can basically going to cover 0, 1, 2, 3, 5, 6. Additionally, you need another path 0, 4, 6. That's all. But the point is, if I want to go
How
for
how
yeah,
we arrive this? So, if you just explain in brief this node
it
coverage
is
and edge coverage, because
intuitional. Like you need to cover all the nodes, right? So you need to just find a path within this which will cover all the nodes, right?
so cover means are we just talking in terms of that? Are we able to reach to 6 node end node, or
Yeah.
see
So the path,
node coverage? Yeah,
so the path
node.
should go through all these nodes.
So okay. So, actually confused with the edge coverage, node coverage, and edge pair coverage. So if
I'm
node
going for
coverage is
age
something
next.
that we,
I'm going for age.
yeah.
So age
No,
means
so just wait. Yeah, sorry. Just focus 1 minute for the node coverage. So you are talking if we have been asked to give the test requirements for the node coverage. So what are those means? In this case, are we talking if
7
just we
nodes.
talk about the prime part? Only 7 nodes, 0, 1, 2, 3, 4, 5, 6, right?
Yeah,
That's it.
that is the test coverage. Sorry, test requirement for node coverage.
Test requirements for the node coverage.
Yeah.
But sometimes see the questions being asked like they have given the complete test path, and is it comes under the node coverage? So that confused us. Why they should asking individual node wise, right? They shouldn't combine the collection of node and they ask that is it comes under the node coverage or edge coverage.
No, it's okay. Like
So that I
the
in
question is
terms of the
again,
yeah.
see, test requirement means what are the things your test path should cover. So in node coverage, all the nodes should be covered in a test path, in the given test paths.
In a sequence manner, in the sequence it is given in the direction, right? That's what.
Because test path is what it is a path which starts from the starting node, ends at the end node. That's all. And whenever I say path, means it should be in a sequence, right?
Okay.
But my question is, what I have written here, 2 paths, does it also do a edge coverage? Edge coverage means all the edges has to be covered.
So edge coverage means we'll have two nodes and one group, right? That's the edge, one edge.
You need to cover
We'll have
all
to
the
mention.
edges. That's all.
But if we can name it those edges, we'll have to give the two nodes as a one edge.
Yeah, that's definitely consecutive 2 nodes, 1 edge, right?
Right.
But my question is, does these 2 test path cover all the edges or not?
Yes, it
No.
has covered bit to combine, because if we talk about individuals, it doesn't cover the complete edges.
It will become a edge coverage also if I give it 4 here. Otherwise, this edge won't be covered, right? But if I say 0446, 0446, then it is a node coverage also, edge coverage also.
0446. So okay. So is it that all the node coverage is the subset of edge coverage?
Edge coverage subsume node coverage, right?
Yeah,
That's the
that's what. Correct,
statement.
correct.
That means all the edge coverage test paths obviously cover node coverage, but reverse is not true, because if you have already seen, if I remove even this, it is a node coverage, but it is not edge coverage, right?
Okay, okay, okay. Right. So ideally, I just wanted to interpret in my term the sequence of path whenever it is given in the question. If it is a continuation, if two nodes in continuation, so is edge, and that set of coming to the end node by node 6, then we can say it is a edge coverage if they have combination of correct set of edges. And if we have a correct set of nodes and it reaches to the sixth node, then we can as a node coverage, right?
Let us talk in the software testing terms. We need to find out the test requirements. All the nodes in a graph is your test requirement for a node coverage. So you need to find out the test path which will fulfill the test requirement, that is all the nodes, right? Whenever you go for
Mm.
a edge coverage, your test requirement is set up all the edges. So first thing, find out all the edges inside your graph. Now you have to find out the test path so that it covers all the edges. Then it is a test path covering the or giving the edge coverage, satisfying the edge coverage. That's all.
Right. Got it.
If you
Thank you
want
so much.
prime path coverage, find out all the prime paths, find out the test path which will cover all the prime paths. That's all.
But node coverage, edge pair coverage have no relation with the prime path coverage or test prime path
Prime
coverage, right?
path
Means we can
rather,
have that.
subsume all of them.
Yes. Right. Correct. Yeah. Thank you so much, sir.
Thanks. Yeah, Abnan, you want to show the example?
No, sir. I'll be taking it in the next live session maybe because we are short of time already, and I want to explain it in detail rather. So it'll be
Okay.
better if I
I,
take
I
that.
just want to check out that thing.
Yeah, simple paths, right?
Just take a minute. Just I got a little confused over there.
Sure.
Uh,
Meanwhile, if anyone of you is having any questions, you can ask. So one point that I'd like to mention here is that, see, in some sense, if you think about it, take a moment to think about it that way. So when I say path, right, everything is a path, right? We're talking of graphs. So what is there in the graph? Graph is having vertices and edges, right? So vertices are these circles, right? The circles that are there. These are vertices or nodes, right? And the arrows that are drawn between the nodes are called edges, right? So we have to follow that. Now, what is a path? Okay. So according to our definition, a path is having a length. Okay. So you have to understand that a path can have length 0 also. So what do you mean by zero length path? That basically is your node itself because you're not going anywhere. So let's say I am at 0, node 0, like node with label 0. I'm there. So I say I am at that point, and then all the 0 length paths would be all the nodes basically. So your 0, 1, 2 individual nodes that are there. All these are 0 length paths. Basically, the length of the path is determined by the number of edges you have. So when I say 0 length path, it means it has no edges. So what is the thing that has no edges involved? It is the nodes, right? So you are at a vertex. So for example, I am at 0 or at 1 or at 2, right? I'm not going anywhere. So that is a 0 length path in itself. So that is by definition. Because if you extend that, then you make it like 0, 1, okay? 0, comma 1. So that becomes your edge, one edge between 0 and 1, right? So if you say 0, comma 1, then you are going from 0 to 1. So you are following in order. Whereas if you are writing 1, comma 0, then you are coming back, right? So you have to follow the sequence. That is about the path itself, and so on and so forth. Now, what node coverage says is that every 0 length path must be covered, which means that every node should be reached. Okay, you are starting from somewhere. You are starting from the initial vertex. You want to go to the final vertex, okay? And in between, you have to visit everything, right? So think of it as places that you want to visit on a map, okay? So it's like a map. A graph is like a map. I'm starting from somewhere. I want to reach a particular destination, right? But I have this constraint of I want to visit everything that is there, okay? So that will be my node coverage. Now, how I am visiting may vary, right? I mean, like it is up to you. How do you want to visit that? Okay, you have to visit everything. So that is node coverage. Now, edge coverage is that you have to cover all the edges that are there, which is to say that you have to visit every edge that is there. Okay. So if you're not visiting every edge, then that will not be edge coverage. Now, what happens as a consequence of edge coverage when you are coming for every edge that is there, then implicitly you're also covering for every node that is there, right? Because you can only reach somewhere by visiting some edge, right? By following some edge, you reach somewhere. So if you are following all the edges, basically you're also visiting all the places that you have. Okay, so that is the difference between node coverage and edge coverage. Is this clear? Then we'll move on to edge pair coverage. Whoever asked that question, I'm sorry, I forgot the name. Nishant, right?
Yeah, I'm there. I'm there.
Oh, yes. Is this clear? The difference between node and edge coverage?
Yeah, I got it. I got it. I got it. Actually, I confused because I thought that node coverage shouldn't have single node. So probably the question probably confused me, but
Okay,
conceptually
okay.
I got it. Yeah. But
No,
thanks.
it's okay. Yeah, yeah. So zero length path basically is your node itself.
Yeah.
And so on and so forth. So basically we are extending it. When we say edge pair, basically you have pair of edges. Okay, so you say path of length 2 basically. So 0 1 2, so there are two edges involved in that. From 0 to 1, then from 1 to 2, so there are two edges that I am following, right? I need a way to go from somewhere to somewhere, and that way is the edge basically. So I go from 0 to 1, then 1 to 2. There are two edges involved in that. So it's a path of length 2 because the length of a path is basically determined by the number of edges that are involved in that path. Okay, and the sequence, of course, you understand that you have to follow that in the order, basically. And also requirements is what we need to cover for. When we say a node coverage, what we mean in software testing terminology is that you have to visit all the nodes. Now, how are you doing it may vary, right? So the test paths may vary, of course. The only constraint is that your test requirement, what does the test requirement say? If it asks for the node coverage, then you have to cover for that. If it is asking for edge coverage, then you have to cover for that. If it is asking for uh, edge pair coverage, then you have to do that. Whatever your test requirement is asking for. Now, interestingly, if you do prime path coverage and the process by which we find the prime paths, you understand that, you have seen that now. So the idea behind using prime paths is that if you do prime paths, then a lot of other coverage is subsumed by that. So you are covering for node coverage as well as for edge coverage, as well as for, I think, edge pair coverage also, if I'm remembering correctly. So a lot of other criteria is already getting subsumed.
Af-
If you're doing
Afnan, can I
this.
interrupt? That
Yes,
that
please, Anand. Yeah.
that actually was the question to I posted on Discourse. So the edge pair coverage is not subsumed by a prime pair.
Okay. Okay.
Prime
Then
path.
yeah.
That
Yeah. Then
actually
in
was
that
the
case,
question. So I'm still confused about why it is not, but that is a different question.
yeah. Good that you brought up. Actually, I was also not I was not sure of the fact. Yeah. Now
Yeah.
that I recall it, I also remember that edge pair coverage is not being subsumed by
Yeah.
prime path
Right. Right.
coverage actually, because it specifically says you to cover every edge. Now, in this process of extending paths, as you've seen, right? We are extending paths. So you start with length 0, and then we extend that to see what can be extended, what cannot be extended, and depending on that, we are adding symbols to that. So if it's a loop, then we are adding asterisk. That is just a notation, nothing fancy about it. And if it is terminating, like we cannot extend it further, then we say it's exclamation. And after that, whatever we get, like all the loops plus the longest terminated paths, such that it cannot be extended. Of course, that is the definition. It says a maximal simple path. That is, you cannot extend it, and it is a simple path. So in that case, that will be your prime path. Now, it so happens that when you have all these things, and whenever we say something in definition, we say it in general, right? So we cannot say, because there might be examples. I'll try to come up with a counter example wherein you'll be covering for prime path coverage, but you will see that it is not matching with whatever your edge pair coverage requirements were. So in that case, subsumption cannot be guaranteed, and therefore we don't say it in general. But yeah, node and edge coverage, I think it's subsumed. So for most practical use cases, prime path coverage is sufficient, but of course we have other coverage criteria also, which we'll see going forward, in later weeks. Okay.
Yeah, this is to confirm like all the simple paths are actually all the simple
All
paths.
simple paths, right? So, yeah,
Right.
exactly.
So I
Exactly.
got a bit confused. Yeah, those are
Mhm.
asterisks and those exclamations are the max of the simple.
Yes, yes,
If
exactly.
you have to count all single, zero length, one length.
Everything, yeah. Basically, definition says that a simple path is a path where no nodes are repeated, except maybe in the case of loops, where the first and the last must be the same. So if I'm starting with 1, I must end at 1, and in between there should not be any repeats whatsoever. Okay, so that is your simple path. That is a loop also. Okay, and if you're trying to extend that further, then of course it'll cease to be a simple path. So for example, I'm at 1 to 1, then after that I can continue, but it ceases to be a simple path then, because there'll be a repeat. So I cannot do that. Then I put an asterisk there. Okay, now in the other case, when you have something like, kind of a dead end, right? After that, if you repeat, you're going to get going to get a basically a non-simple path. Then in that case, you'll also put an exclamation mark. And of course, in the final node, that is like the double circle one, in that one, of course, that is the last node anyway. So of course we cannot go from there to anywhere else. So anyway, we put that exclamation there. So that is all. I hope it is clear. Any questions at this point?
So Afnan, I have a few other questions which is not exactly related to this.
Mhm.
Yeah, so maybe these two are. So I've also heard about the terms called side trips and detours.
Okay,
So,
okay,
but
yeah.
I haven't seen any questions on them, and I don't really understand the relevance of understanding, I mean, studying them.
I see. So I think in the first 2 weeks we have not discussed it
We
here.
did. Actually, there is in the second week, I heard the
Yeah,
side
yeah,
trips
it's
and
there in
detours.
second week.
No, I mean it may be discussed, sir, but I think we have not provided any questions on that. I see. I
Yeah,
mean,
yeah, there is no question on that.
no,
That's
there is Anand. No, the last question in GA2 itself, it has that side trip, right? Not the
okay.
last, sorry, the 10th question. Question number 10, graded assignment 2, you have that, right?
Okay, does it mention the name? Okay, I may have missed it.
It says the options
Okay.
are asking the test path P towards the sub path with this side trip and so on and so forth. So it must be there, I think. Yeah,
Okay.
there are not many questions, I understand, but yeah, there are a couple of them. Yeah, so, yeah, we'll discuss that maybe. I mean,
Okay.
time won't permit me to start a new discussion on that right now.
Yeah, sure. No problem. And the second question I have is I've heard I think even in today's discussion in the morning, so there was this mention of we could use the IDE to create the graphs from the code.
Okay.
So I didn't understand how to do that. I tried to do that in VS Code, but I failed. Some extension seems to, but I couldn't
No, no,
get that.
kind
Can
of
I?
extension they have removed it actually. Even Visual Studio also they have removed, but VCO I don't know. We need to check it.
There might be other extensions that are added to the IDE to enable that functionality.
It
I'll
may
have
be
to.
there on VCO actually.
Maybe.
Other they have all removed it. I have checked all.
Okay. So
It's not
okay,
there
we
right
can
now.
have an open session discussing specifically that, I think, because that is at this moment I think it is not specifically discussed in this course as such. But if you want to discuss that, we can take this in one of the other open sessions that are there. Maybe in the next one, or would
Yeah,
that be okay,
I
Anand?
think that would help. Yeah, if you could do that in
Definitely.
some
Yeah.
live session. Yeah.
Yeah,
Thanks.
definitely. Thank you. Anyone else? I think Nishant had a question. Would you like to ask, or is that clear?
No. Actually, Anand rightly mentioned that I missed to ask the question on side trip and detour. So yeah, but we'll discuss next
Yeah,
session.
we'll discuss it, of course, theoretically, and of course, the graded assignment is there. Is there any specific doubt? If you want me to discuss it right now, I can do that, because I understand that the deadline, only a couple of days are there, and I think, I mean, before the next live session, you'll have to answer that question. So, if you want to, yeah.
Yeah. So if you have a time, just talk in a minute or so. See exactly how to
Okay. So
subpath and
there is
so.
one slide that nicely captures all the I mean the tour, the T tour and the side trip. So I can do that. I'll just quickly share my slide and just show you one slide. I'll not go beyond that. And maybe you'll be able to understand. In case you need further clarification before the next live session happens, please feel free to ask on Discord, or if required, we may organize an open session also. Though this week it might be difficult, but I'll try. By the way, let me share. Let's try covering it quickly possible. Yeah. The open sessions can be taken. It's just that this week, not sure if I can conduct one. Just give me one moment, please. I'm getting to that slide. Okay. Sure. Okay. Please let me know if the screen is visible.
It is now.
Yeah, it's visible.
Visible, is it? Sajid? Is it not visible? Sorry.
Yeah, it is visible. Yeah. I mean,
Oh, okay.
just now you removed
Okay,
it.
okay. Sorry. Yeah. All right. So yeah, these are the three things. Okay. So firstly, understand the tour. What the tour is. Tour is basically touring, like visiting, right? So this is the main part. So this concept of side trip and detour is always in reference to a path. Okay. It is, when we say side trip, it is relative. Okay. It is not like, it is not in absolute sense. Side trip according to what? Okay. So there has to be a main path in some sense. I'm calling it main path. We don't call it the main path, but you get the idea. Okay. So there has to be a path in relation to which you are calling something a side trip or a detour. Okay. So this path is the main path. In this diagram that we have, there are three diagrams. Okay. So the first one is the main path that they are, they have illustrated here. 1, 2, 3, 4, 5. Okay. This is the main path in some sense we're following. So it says touring the prime path, but it could be any path in general. Need not be specifically prime path, but yeah, this is the thing. So the concept is this is the main path. Now, what happens in a side trip is, okay, and do notice the difference here, please. In the side trip, you are visiting your original path. So you intended to visit 1, 2, 3, 4, 5, and you're doing it. So, compare it with the first graph that is here. You're also following the same path. So 1, 2, 3, 4, 5. But in between, we have also visited 6 and come back to 3 and then continued along the same path as previous. Okay. So from 3, we were going to 4. So the edge 3, 4 was being followed here, which is the case here also. And then we are going to 4 to 5, which is also the case above 4 to 5. That is the same. Only thing is that after visiting 3, we visited 6 and came back to the original path and followed it. So that's a side trip. Now, what is the difference between a side trip and a detour? In a detour, we don't follow all the edges in the original path that were there. So we take an entirely different route. Okay. But notice that we are still visiting all the nodes that we were visiting in the original path. So here what happens? After we start from 3, we go to 6. Okay. And from 6, instead of coming back to my original path, which was 1, 2, 3, 4, 5. So 3 to 4, I was going. The original plan was to go to, 3 to 4. But here what I did was I came to 6. From 6, I'm going to 4 directly instead of coming back. And then I'm going to from 4 to 5. So that's okay. But not all edges are being followed. Notice that all nodes are still followed. So that is the difference between side trip and detour. Is this clear?
Sorry. So you are saying if we go 1, 2, 3, 6, 3, 4, 5, then that is called side path,
Side trip. Yeah.
side trip. And if we go 1, 2, 3, 6, 1, 2, 3, 6, 4, 5,
Hmm.
then it is a detour.
Detour, because you basically did not follow your original intended path in some sense. Your original plan was to go to 1, 2, 3, 4, 5, right? So in that, what would have happened? You would have followed the edge 3 to 4, the one that I'm highlighting. Hope my highlights are visible. Okay. So this one would have followed according to the original plan. This one. That is why I said it is in relation to one path that is there. So this was the original path. Okay. Now this is a detour in relation to this path that I have. This one, the last one. because I'm not going to 3 to 4. Instead, I'm taking a different route of going to 6 and then going to 4. In this case, I'm visiting additional nodes, but still the original path is followed. In this case, the last case, the path itself is different. We are not taking the edges which we were taking in the original one. So now coming back to the this definition, it says about the side trip. This is about the tour itself. So that's okay. It needs to be a sub path, that we understand. But then this one says a test path P towards a path which is inside of that Q with side trips if and only if every edge in Q, right, that is the the subpath, is also in P. You're following that in the same order. So you're following every edge, okay? And this is side trip, and that is what exactly happened in this case. You're still following every edge. So my edges were 1, 2, 2, 3, 3, 4, and 4, 5. I'm also in the side trip case, also I'm following 1, 2, 2, 3, 3, 4. This one. I hope my highlights are visible. 3, 4, and 4, 5. So that is still is considered a side trip because I am visiting all the nodes which I intended to visit originally, as well as I am also visiting all the edges which I plan to visit initially. I mean, visiting the edges also in the side trip, and that is what the definition says. And contrast this with detours says a test path P towards subpath Q with detours, if and only if every node in Q. So this is a relaxed condition in some sense. It is not talking about the edge, it is talking only of the node, okay? So you may take any path, but you need to visit all the nodes that are there. Okay, NQ is also NP in the same order. So it says that you have to visit all the nodes, not necessarily all the edges. So for example, 3, 4 is not followed. I'm taking a different path. So instead of going to 3 to 4, I'm following 3 to 6 and then 6 to 4. This is a new thing that is there, right? 6 to 4 was not there previously. 6 to 4 is not there in the original one. But here we are having that 6 to 4, and 3 to 4 is not followed. So that is a detour. Please continue.
Afnan, see, let's assume I have given a path without giving any diagram, right? So we don't know which have a direct edges. They have just given the path. It could be that some 1, 2, 3, 2, 3, 2, 4, 6, 1, 2, 4, something like that.
Right, I understand. I don't want to go in too much detail about that, but that would, because that would mean talking about the graded assignment, which I cannot do unfortunately at this moment. But you understand, go through this definition only. It says that a test path is touring only if it is a subpath. So understand what a subpath is. That is one. The other thing is that pay attention to this practice says every edge. Now you can make it out, right? Only from the path itself. No need to have the diagram. You can just make it out from there, right? That whether or not every edge is being followed or not. And here the condition is relaxed.
Okay.
It just says about the node, right? So you understand the difference between the two. You'll be able to make that out, right? Of course, I cannot mention that at this moment.
Okay, fine, thanks.
Anand, is this clear? I think you were asking about this, right?
Yeah.
Okay, thank you.
I basically wanted to. I mean, this was not the exact question. I understood what this was, but I wanted to understand how these factors and
Okay.
these will come into our test case design. So
definitely, okay. Yeah, that we'll talk about later, maybe. Yeah.
Okay. Yeah. Sure.
Definitely. Thank you. Okay. Hello, Puneet. I think if there are no other questions, then we may as well close for today and then meet maybe in the next live session or even before that. Okay, no audio. Puneet says no audio. I'm not sure if. Are you able to hear us at least? If so, please. I don't know. Okay. Thanks.
So Afnan, just to clarify that point on the creating the graph. I mean, we can do it during the next live session? Is it possible?
I'm so sorry, I missed that. Which graph? Creating which graph?
Creating the graph.
Oh, CFG from the code.
ID.
Yeah, definitely, Anand.
Okay. Yeah. Thank you.
So this week is particularly tight. I think for me at least, it'll be difficult to conduct any open sessions in between. But I'll definitely be joining in the next live session.
Sure,
That is
that's okay.
6th
Perfectly fine.
of February, right? So yeah, in that maybe we can discuss that. Yeah, sure.
Okay, yeah.
All right. Any other questions, or can we close for today? If so, then we can stop the live streaming, sir. Also, if possible, can you stop that? Thank you all for joining.
Thank you. Thanks, everyone.
Thank you, Arup sir.